We don't need Sergi anymore. We don't need the Sergi Meister. What the heck? Okay. Audio.
Hello. Can you see well? Let me know, either chatting or unmute yourself and let me know. Do you see well?
Yeah, we can see the, or at least I can see the paper.
Okay. How about Hunter and Lily? The other ones? You can, yes, yes, yes. Okay, thank you very much. All right, so that's how we're gonna do it for the end of the semester. I will gonna try. Now I only have not a lot of students there, so I'm gonna a little bit kind of stall a little bit. Hopefully more students will join. We only have 8 of you guys now. So the way I'm gonna run this is exactly like I run the class. So I will try to do exactly the same. Meaning at the beginning, I will go over the problems that I assign. We will solve them. So you guys ask me question, which problem you had trouble with, we can do them. And after that, I will introduce the new material. Okay, you guys have the lectures in front of you. So I will take the new material and I will go through the lecture step by step. And as usual, I will assign homework for Wednesday, and Wednesday you guys will have to do the homework and we go over them and we introduce new material. Now, I don't see your faces, as you guys know, so you have to try to tell me, either use chat to tell me, you know, we don't understand, I understand, or anything, or you can unmute yourself and tell me, can you repeat? Okay, so because I don't know what's going on, I don't see your faces, so I don't know whether you follow me or not. So you have somehow to help me knowing what's really going on. All right? So how are you guys been doing? Staying at home safe? Okay. So how did the homework go? Anybody has questions? Whoever has questions, unmute yourself.
The format for 17, 18, and 19, I wasn't really sure what format to give those answers in.
Okay, fair enough. Any other questions? I'm gonna go over a little bit the whole section slowly. I mean, just remind you, and then I will answer Dijon's question carefully. But I'm a little bit slow. I'm hoping more students will join. And next time I'll start at 5. I mean, they have to, you know, you guys have to join on time. Okay. All right, so I will start. I heard your questions, and I'm gonna do definitely 17, 18. And I'm gonna do also number 8, just to make sure we're all on the same, we all know how to do those problems. So I'm gonna do 8, 17, 18. And if you guys have questions, you let me know, all right? Please unmute yourself and talk, because that's the only way I know what is in your mind, okay? So I'm gonna start. All right. And please, if you don't follow, you have to help me. All right, so let's start. Let us recall what we did last time, the last thing we did. We talked about quadratic functions. And we said that quadratic functions, they have the form. Okay, who's ever making noise in the background, unmute yourself. So quadratic functions, they have the form f of x equal ax squared plus bx plus c, where a different from 0. That's what a quadratic. So it changed different from linear. In the linear, the higher power of x is 1. Quadratic, the higher power of x is 2. And the graph of it is just a parabola. And it depends on a, whether a is positive or a negative. If a is positive, it's a parabola concave up, means the curvature is upward. If a is negative, is concave down. It means the curvature is down. Now, parabola have vertices. That's the vertex, and that's the vertex of the parabola. And the x-coordinate of the vertex is minus b over 2a. And to find the y-coordinate, we just plug in minus b over 2a in the formula for the function. And finally, the zeros of a function are the values of x where the function is 0. They are the x-intercept. So we have a 0 here, and these are the zeros of the function. To find them, we're going to set the function equal 0, that is ax squared plus bx plus c equal to 0, and solve for it. And how we solve? We either factor, and if we don't know how to factor, we use the quadratic formula. So that's a summary of what we did last time. So what I'm going to do today is actually going to go through problem number 8, just to make sure we all know how to do that, and your classmates' questions, which is number 17. Okay. All right, so we're looking at number 8. All right. So the question is, we have the following functions. F of x equal x squared minus 6x plus 5. So that's definitely a quadratic. And what is my a in this problem?
1.
1. What is my b?
-6.
-6. And my c here, quick.
5.
5. Thank you. All right, now I'm going to go through this whole problem because it's actually summarized everything we did last Wednesday. So my first question, the first question is, what is f of 2? So that's simply plugging 2 into the equation. So you guys give me the answers as usual. Plus 5. So how much do we get? 4 plus 5, 9. 9 minus 12 minus 3, correct?
Yep.
Okay. B. What are the coordinates of the vertex? So this is a parabola. We're going to start sketching the graph of it slowly, slowly. And we know it's a parabola going up because A is positive. So I want to find the vertex. So first we find the x-coordinate. So the x-coordinate is minus b over 2a. All right, let's compute that. Minus. B is minus 6 over 2a over 2. It means minus 6 over 2, it's minus 3. The x-coordinate is 3. So 1, 2, 3. So the function is going to have, since a is positive, so the parabola is going upward. So we know that the function will have its smallest value at 3. But we need the y-coordinate. To find the y-coordinate, we just compute the output at 3, which is going to give me 3 squared minus 6 times 3 plus 5. And this is going to give me 9 minus 18 plus 5, which is going to give me 9 plus 5. That's going to give me 14 minus 4. Okay, so the vertex, the coordinate of the vertex are going to be 3 and minus 4. All right, so this is nice. I already have a good idea what's going on. 1, 2, 3, 4. That's minus 4. It means right here, my parabola will bottom up. It's going upwards, so my parabola is going to look somewhere like that. And this line here is like axis of symmetry. It means we have symmetry with respect to this axis. So we already have a very good idea about the graph. What's the value here? Is it easy to figure it out? Quickly, I want one of you to answer.
Oh, that's the y-intercept.
That's the y-intercept. So how do we get that?
When x equals 0,
Right.
so it would be plus 5.
Exactly, we plug in 0 in the expression of the function. So if I want the y-intercept, I plug in the 0 in the expression of the function, and I'm getting my 5 right there. So you already see how good of a graph we have. Now, see, is the graph concave up or down? If it is positive, the graph is concave up. It means it turns upward. So that's concave up. D. Okay, they want us to find on which interval is the function increasing. So by sketching the graph a little bit, it will be easy to figure. So, what's happening? So f is increasing for which value of x?
3 to infinity.
Exactly, for all values of x that has the property x bigger than 3, or for x in the interval 3 plus infinity. Either way you write it will be absolutely correct. And it's decreasing here. So it's decreasing everywhere else. Decreasing for x less than 3. So knowing the vertex, we know a lot about the behavior of this function. Now, the range. What is the range of f? It means the output values of f. So who would like to give me the answer, and also quickly? What's the range? Remember the range, the output. What's the range?
All numbers greater than or equal to -4.
Is he correct? Of course. The range of f is all values of y. Remember, the range are the output value. That's the smallest value. And then we are going up. All values of y such that y is greater or equal to -4. I'm actually looking at the output value. Very good. So this problem is really telling us to do everything. It's a good review for the whole thing we did, the ones that before the spring break. Determine the zeros. Right now, I am after those. What's this and what's that? To determine the zero, so we're gonna set f of x equal to 0. And so for x. Very good. So we're gonna put f of x, which is x squared minus 6x plus 5 equal to 0. So that's a quadratic equation. We're gonna solve it. So we have two ways. First, we try to factor. And crucial, you try to factor. If you don't know how to do it, then we use the quadratic equation. So first, always try to factor it out. So now, can we factor this one? Means, can I find two numbers? When I multiply them, I get a 5. And when I add them, I get a -6. So 1, 5 are the possibilities, but those, if I add them, I get +6. A better possibility is -1, -5. So we're gonna factor it out. X minus 1, x minus 5 equal to 0. And every time you factor out, check that your factorization is correct. It means try to go backward and see if you get the same thing. So I distribute x times x, that's x squared, minus 5x minus x, that's minus 6x, minus minus, it's a plus 5. So always double check yourself. Are you factoring correctly? So now you have the product of two terms equal to 0. So it's gonna give me x minus 1 equal to 0, which give me x equal to 1. X minus 5 equal to 0, x equal to 5. And now we have a very good picture. So if I go to the graph now, this is where it intercepts the x-axis. This is my 1. And right here is this 5. All right, any questions so far? If you have questions, you can use in mute or chat, whichever you're more comfortable with. All right, so let us finish this problem. So part G, so I'm gonna put the graph again. So we keep focusing and interpreting everything graphically. So this is my graph again, kind of. So this is my vertex. These are my zeros. And this is happen to be the intercept. Now, what do they want me to do? Now they want me to do, I'm at part G here. Determine the number for which f of d equal to 12. So we want to find all the d's such that f of d equal to 12. So graphically, what do they want us to do? Graphically, before we do it algebraically. Sorry, I need. Okay. So graphically, it means the output is 12. This is 12. And I want to know all the input. So I'm going backward. All the input where the output is 12. So clearly, at least from the picture, we're going to have 2 values. So let us go ahead and solve. So I want d squared because I use the letter d. So I'm going to use the letter d minus 6d plus 5 equal to 12. And I want to solve for d. Okay, what is the first step? I want an answer this time. What is the first step? We've talked about that early on. What should you do first?
Subtract 5 from both sides.
Exactly. We have, no.
12 from both sides.
We have to subtract 12.
You want to set the equation to set the equation equal to 0.
Right. We have to subtract 12 equal and set it equal to 0. So whenever you have a quadratic, because if I did what you guys told me, and I did d squared minus 6d, so this is crucial to learn this, equal 12. And I subtract 5, I will get this equal to 7. And then what am I supposed to do after that? I'm stuck. How can I solve for d? So the idea is to make the right side 0 and put everything else on the left side. And then I can solve either by factoring or the quadratic equation. So I'm going to subtract 12 from both sides. And then this is going to give me d squared minus 6d plus 5 minus 7 equal to 0. Now I have a quadratic in a format that I recognize. Again, we're going to do what we said a minute ago. I try to factor, I fail, I use the quadratic formula. Now, can I factor here? Did you guys try it? Who can give me factors?
-7 and +1.
-7 and +1. Okay, let's try them. D minus 7, D plus 1 equal to 0. And now what are you supposed to do before you solve?
Check.
Check. Multiply, make sure you're going to go back here. D times D, D squared, plus D minus 7D, that's minus 6D, minus 7, we are all right. So I always double check myself. And now, 2 terms, you multiply them, you get 0. It means either this is equal to 0 or D plus 1 equal to 0. The first one tells me that D is 7. The second tells me D equal -1. So now I'm back to my graph. My graph suggested one of the values is going to be negative and one is actually positive. So it actually suggested that's what's going to happen. So now this one is the -1 and this one right here is the 7. All right. Okay, we still have one part from this problem because it helped me to review everything with you. So the last question is, determine the number d such that f of d equal to 9. So we want to find d where if f of d equal to 9. So again, we're going to set d squared minus 6d plus 5 equal to 9 and solve for d. All right. Again, what's the first step? What's the first step?
Subtract 9 from both sides.
Subtract 9 from both sides to make it equal to 0. So if I do that, I will have d squared minus 6d plus 7 minus subtract 9. So this is going to give me plus 5 minus 9, which is going to equal to minus 4. All right. So if I do any mistake, you guys, it's your job to correct me. Very nice. Now, can I find two numbers? When I multiply them, I get minus 4, add them minus 6.
No.
No.
Try them. You won't. So you won't be able. So we're going to use the quadratic formula now. And what does the quadratic formula tells us? That d, the solution, is of the form minus b plus or minus the square root of b squared minus 4ac over 2a. And in class, I split it into two. It means we have two solutions. One, the minus b plus the square root. And one is minus b minus the square root. Okay, so let us first try to compute this b squared minus 4ac. That you remember what's called? It's called the discriminant. Let us compute it. To compute it, I have to go back to my equation and ask myself, what's the a, what's the b, what's the c in here? So let us see. What's the a?
1.
1. What's the b?
-6.
And what's the c?
-4.
-4. And now let us compute this, and then I plug them into my formula. So that's going to give me minus 6 squared minus 4 times 1 times minus 4. That's 36 minus plus 16. 36 plus 16, that's going to give me a 52. Okay, now we can plug it into the formula very easily. So now d, there are two values. One is minus b. It means minus 6 plus the square root of 52 divided by 2. It means 6 plus the square root of 52 divided by 2. The second one is going to be minus 6 minus the square root of 52 divided by 2. It means 6 minus the square root of 52 divided by 2. All right? Questions? Please ask questions. Now we're going to evaluate this on our calculator just to estimate, because this is not a number that we really know what it is. So it's nice to know almost how much this number is. So we're going to compute it. 6 plus the square root of 52 and the whole thing divided by 2. So the first one is, I'm going to write the answer to 3 decimal point, 6.605. And the second one, it's 6 minus the square root of 52 and the whole thing divided by 2. And the second one is minus 0.605. Okay, so this provides us with a review of basically what we did on Wednesday. Now I go back to answer the classmate questions. I'm going to look at number 17 and then we proceed. Okay. Sorry, I'm looking for papers. So number 17. I hope you guys have the book in front of you. The question is, what is the largest number assigned by the function f of x equal minus 3x squared plus 24x? So this is my function, f of x equal minus 3x squared plus 24x plus 100. And the question, what's the largest number? Here, they're asking about the largest output number. That's what they mean by that. What's the largest output value that the function has? Now, very simple questions. This function that you see, is it going to have a largest value or a smallest value?
Largest
I want an
value.
answer. Largest, because?
The equation is negative.
Not the equation. What's negative? Be precise.
The x squared value is negative.
No. Be more precise.
The function's negative?
A is negative.
Oh.
A is negative. That's what tells you. A. What is A here?
-3.
Right. That's negative. It means the graph is what we call it concave down. So the graph going like that. That's why we're going to have a largest value. So the question now is, what is the largest value? So how are we going to find the largest value? I want an answer. Anyone? What do you need to find to be able to tell me what's the largest value that the function takes?
The vertex.
The vertex. Is he correct? If I know the vertex, so if I know the vertex, right here, I know what's the largest value the function takes. That's how we're gonna know that. So the vertex is not hard to find. First we find, so here my A is, I need, my B is 24, my C is 100. To find the vertex, I need the x coordinate of the vertex. So the x coordinate is minus b over 2a. It means minus 24 over 2 times minus 3. That's minus 24 over 2 times minus 3, that's a minus 6. Minus minus, that's a positive. 24 over 6 is 4. So that's give me the x coordinate of my vertex. When they want the largest value, it means they need the output value in this problem. So to find the largest value, I need what is the output value when x is 4. So I need the y coordinate of the vertex. So I need f of 4. What is the output at 4? It's minus 3 times 4 to the power 2 plus 24 times 4 plus 100. And then this is gonna give me minus 3 times 16 plus 4 times 24 plus 100. So this is gonna give me minus 48 plus 96 plus 100, which is, how much does this give you? So we need minus
148, right?
What? It's negative 48, correct?
148. Because half an x is 48.
Yes, 148. Thanks, Roxanne. So this is 148. So what does it mean? What is the largest number assigned by the function? It means they're asking for the output value. So the largest number is 148. So, or sometimes we call it what's the maximum value obtained by the function. So sometimes I say what's the largest or what's the maximum value obtained. The maximum value is 148. Okay, any other questions from the homework? Please feel comfortable before we move on to today's lecture. Okay, all right, so today we're gonna start chapter 3, section 3.1, and we're gonna talk about exponential function. So first, we have seen so far two types of functions with two formats. We've seen linear. It means the form is mx plus b. Then quadratic. Quadratic is a x squared plus bx plus c, where a is different from 0. Today we're going to see another important type of function called exponential. Extremely important type of function. First, what's the form of it? An exponential function is a function that has the following form. A constant a times a certain number b to the power x, where a and b are constant. Note something that f of x is a times b to the x. So it means that in an exponential function, and that's where the name exponent coming from, the independent variable of the input x is an exponent. That's why it's called exponential, because x is the exponent of b. So let us take one example of this. So I take the function 4 times 2 to the x. I wrote it in such a way that you understand. You're taking the constant a and you are multiplying it by 2 to the x. So in this scenario, this a is 4, and my b is a 2. So let us evaluate this function. I mean, how to work with it. So what is f of 0? It means x takes the value 0. It's 4 times 2 to the 0. Now, anything to the power 0 is 1. So 4 times 2 to the 0 is 4 times 1 equal to 4. Okay? What is f of minus 1? It means x takes the value minus 1. So f of minus 1 is 4. You multiplied it by 2 to the negative 1. Now we remember our exponent. What does 2 to the negative 1 means? 1 over 2. So that's 4 multiplied by a half, which is equal to 2. Make sense? Okay. For those of you who don't follow or have a question, chat for me. Tell me I didn't follow you. Is that clear? Now, what is f of 3? It means x takes the value 3. It means 4. You multiply it by 2 to the power 3. Okay, that's 4 times 8, 32. What's f of minus 3? Let me write a little bit bigger. What is f of minus 3? Sorry, I thought I had it last year. So, f of minus 3. It's 4 times the 2. The 2 is by itself raised to the power minus 3. It means 4 times, now 2 to the minus 3, remember, when you raise 2 to a negative 3, that's exactly 1 over 2 to the 3. Now we multiply 4 times 1, that's how we multiply fraction, over that 4 over 8, which is a half. Okay? So suppose I'm going to ask you to compute f of minus 4. I give you a few seconds to compute it, and then give me the answer, quickly. Do it in front of you, and give me the answer. One of you will give me their answer. Okay, who's ready?
The answer is 1/4.
1/4. Who agree with him? That's Ethan, right?
Now Patrick.
Patrick, sorry, Patrick. Who agree with Patrick? Anybody? Okay,
Yes,
Patrick, walk me
agree.
through it. Patrick, walk me through it quickly.
Okay, so f of -4 means 4 times 2 to the -4th power.
Mm-hmm.
And that means that equals 4 times 1/2 to the 4th power.
Absolutely correct. Keep going.
And then you multiply across and you get 4/2 to the 4th power,
Which is, go ahead.
equals
1/4.
4/16.
Which is 1/4. Absolutely correct. Right? So now I just kept giving you examples to help you. So f of 1/2, it means 4 times 2 to the half. But what's 2 to the half? Is the square root of 2. Now, f of -1/2. So I will do this one. What is f of -1/2? It means you take 4, you multiply it by 2 to the -1/2. What does this mean? It means 4 times 1/2 to the power 1/2, because a minus go into the denominator and become a plus. It means 4 times 1/2 the square root of 2. So you just multiply across, you get 4/2 square root of 2. So that's how we work with those functions. It's only this 2 which is raised to the power. 4 is not raised to any power, you just multiply it by. Now some terminology. In this formula, f of x equal a times b to the x, a is called the initial value. Why we call a the initial value? Because if you take x to be 0, what's the output? If x is 0, what is f of 0? It's a times b to the 0. But anything to the power 0 is 1. So f of 0 is equal to a. That's why it's called the initial value. It means when we are going to graph the function eventually, if x is 0, the function takes the value a. That's the a in the function. B is hard, and we're going to spend time working with B. B is hard, but it has a name, and it's a name we have to know. B will be called the growth factor, a name that you have to start being familiar with. Growth factor, that's the name of B. Now, what we're going to do today is how do exponential functions arise in real problems? Means what do they model? Why? Where they came from? So today we're going to emphasize only one idea, taking problems, real life problem, and show that they follow this type of formula. So here's my problem. Okay. A person is hired as the salary of $40,000, initial salary. And he's working for a good company. They tell them that you will receive a 6% raise each year. So every year, you will gonna get 6% raise. And we're gonna introduce a function, WT, which is the salary of this person T years after they were hired. Is the picture clear? So you're hired, they give you 40,000, but they promise you that every year they will give you 6% raise on what you made the year before. So my question is, find the salary at equal to 0. It means when he started, after 1 year, and after 2 years. So let us do that. Do you guys know how to compute this? Let's do it. Initially, at 0, how much is he making? 40,000. After 1 year, how much is he making? 40,000 but then he gets a raise of 6%.
40,240.
How much did you say? Repeat.
4240.
Exactly, 42,400. Right?
Oh, is it 42,400? I was
Yes,
saying
because he
4,200.
started with 40,000. Ah, sorry, you're talking about the interest or the whole amount?
No, I was talking about, I had my decimal points off. That's why.
Okay, so he starts with 40 and he get a raise of 6%. Now how we compute the 6% of 40? We take 6%, we write it into as a decimal number. So 6% is nothing more than 6 over 100, which is 0.06. We multiply, then you get 42,400. So initially, he makes 40,000. A year later, he making 42,400. So he earned 2,400 in 1 year. What happened after 2 years? Now his income is 42,400. And after 2 years, they're gonna start giving him an extra 6% of the 42,400. So how much he's gonna make? I'm gonna repeat basically the same process, but instead of 40,000, now I replace it with 42,000. So can you guys do it and check my answer? So this
Anthony
is
did it.
what?
Anthony posted it in the chat.
Oh, thanks, Anthony, sorry. All right, so my answer is correct. Now, is this function linear by any stretch of the imagination?
No.
Linear, remember, it means it grows by the same amount every unit of time. Is this function growing by the same amount? What do you think? Logically, yeah, logically no, because the first time he got 6% of 40. That's the change. The second time is changing by 6% of a higher amount, which is to 42,000. So he's definitely getting a higher raise than the previous year. So it's definitely not a linear growth. Now, if I'm going to ask you how much you will be making after 3 years, will you do the same process? After 4 years, we're going to repeat the same process over and over. So the idea is, can I find a formula so that if I give you any year, I ask you how much you'll be making after 10 years, I'm going to have a formula that gives me how much is learned. Any questions so far?
No.
Okay, so let us find a formula. This is a little bit hard, but not too hard. So to find a formula, we need to look for a pattern. So I can generalize. What we know that each year, what's happening? Every year, his new salary is his salary of the year before, I'm gonna call it the previous salary, plus the 6% of his salary the year before. Make sense?
Yeah.
I'm repeating the process. Every year, his salary is his old one plus 6% of his old one. So we're gonna rewrite this as follows. After 1 year, his new salary is 100% of his previous salary plus 6% of his previous salary. So what percentage of his previous salary is his new salary? It's 106% of his previous salary. So after 1 year, his income is going to be 106% of what his income was the year before. It's his income plus the extra 6%, which make it 106% of his previous income. Now, how do we compute 106% of something? You take the 106%, you write it as a decimal. So that's 106 over 100. You put the decimal in the correct place. So you have here 2 decimals, you move, you get 1.06. It means every year his new salary is 1.06 times the previous salary. So if I know salary at the first year, to find it the second year, I multiply by 1.06 and I get his new salary. So this would lead me to the following. The new salary is always the previous one times 1.06. And that's going to be the main idea behind here. So let me go back and let us use this to find a formula. After 1 year, what's his salary? 40,000 times 1.06. So where's this 1.06 is coming from? It's the 100% plus the 6%. That's the 1.06. Now, if you compute this number, we get exactly 42,400. Do it. Do it. If you don't get 42,400, it means we're doing something wrong. Anybody did it? Yep. Okay. So after 1 year, it's 42 times 1.06. After 2 years, what's going to be his income? It's his income after 1 year times 1.06. So it's his previous income. That's his previous income. You multiply it by 1.06. That's what gives you his income after 2 years. And now a little bit of math. We're almost done. Don't worry. 1.06 and 1.06, we're going to combine them. It's 1.06 squared. So after 2 years, we will make 40,000 times 1.06 squared. So let's check. Is this making sense? Does this give me the answer that we got a minute ago?
Yeah.
Does it? Is it giving you 44,944?
Yes.
It should. That's what's happening. After 3 years, how much he's gonna make? What he made the previous year times 1/6, 1.06. That's how much he makes. The previous year times it 1.06. So every time going from 1 year to another, I have to times the previous salary by 1.06 and I get his new salary. Now combining those two, I get 40,000 times 1.06 to the power 3. Okay, let us see the pattern. 1 year, 40, 1.06. 2 years, 40,000, 1.06 to the power 2. 3 years, 40,000, 1.06 to the power 3. Every year, we multiply by 1.06 what we made the year before. So if I watch this pattern, what's going to be his income after 2 years? After 1 year, to the power 1, to the power 2, to the power 3. So if I plug in here, after 4 years, what's going to happen? It's this income multiplied by another 1.06, which is going to give me 1.06 to the power 4. So if I watch this pattern carefully, after 2 years, the income is going to be 40,000 times 1.06 to the power t. That's an exponential function. This is exactly, this function has the form of an exponential function. So WT is an exponential function. A is the 40,000. That's the initial salary. And the growth factor is 1.06. But how did we get the 1.06? Where did this come from? It's the 100% plus the 6%. So it's 1, that's represent the 100% plus the 6.06, which will represent the 6%. So if I'm having the following scenario, okay, I have an income. And my income,
Michelle looks confused. She wrote a question mark.
Oh.
You guys need to get on the video so you can ask questions.
No, I can't. That will be too confusing. In mute and ask question.
So what you were showing earlier is the same thing, right? Now you're just, but instead of like doing all that math, you're just simplifying it by like raising it to the power.
Exactly.
Okay.
You're absolutely correct. But now I can have a formulas. But if I do it the first way, you have to understand both aspects. First, it's just numerical, you know. Now you realize that there is an occurring pattern. So we use this to be able to find a formula. And that will be the formula. Does this answer make sense?
Mhm.
Yes, thank you.
Yeah. Please ask me questions. So WT is the 40,000 times that. That's my initial, and that's my growth factor. So every time, and in life, there are a lot, if you sometimes put money in the bank, and a lot of times, the bank tell you, okay, I'm gonna give you an interest of, let's say, 2% per year. It means your money that you deposit is gonna increase by 2% every year, the same percent. And the question is natural, how much you're gonna be making after 5 years? And that's where the exponential function really come into the picture. So, but let us finish this problem and let us sum up a little bit what I'm doing. First, terminology. The 6%, it means this percent that increase every year, we give it a name. And it's called percent growth rate. I'm using the word rate, or sometimes simply growth rate. So the 6%, it means the percent that's increased per year, we call it the growth rate. And in the formula, WT, which is 40,000 times 1.06, 1.06 is called the growth factor. So 1.06, we call it the growth factor. And it's always equal to 1 plus the growth rate. So it grows by 6%. The growth factor is 1 plus the growth rate. Okay, question before I move on.
So the 1 means 100% of whatever the thing is.
Exactly. The 1 represents the 100%. And 0.06 represent what?
The growth factor.
The percent.
The
no.
percent that it's growing by.
Exactly. It's the percent by it's growing by. The growth factor is, in my scenario, 1 plus the percent by what it's growing.
Okay.
Is that clear?
Yeah.
So that's the growth factor. Questions before I move on?
So is there always going to be a growth rate, or is it going to be like specified in the question?
We give you the growth rate. We will go over some problems. We will go over some problems, but it doesn't have, we will give you, the growth rate will be given to you. Does this answer your question?
Yeah, thank you.
Okay. Now, what happens if in the following scenario? Suppose we're dealing in a situation where our quantity decreases by the same percent. How do you think this will affect the picture? So now, suppose we have the following problem. In a certain town, the population was 20 in 2010, and it's decreasing by 3% every year. Find a formula for the population after 10 years. So it's increasing by the same percentage every year. And we have to find a formula. How do you think the picture will change in this scenario?
It's gonna, instead of being 1.03, it would be 0.97?
Exactly. So what is so this time, every time we have a decrease by 3%. So in this problem, the population changes by minus 3%. So whatever it was, it's going to go down by 3%. So we say that the growth rate, even though the word growth doesn't make sense because we actually have a decay here, but everybody uses the word growth rate, is minus 3%. So this reflects the idea that you are decreasing by 3% every unit of time. Will the formula be very similar? Will the formula be very similar? Actually,
yes.
The formula, will be very similar. What's going to be the formula? And now we study it. It's going to be your initial amount times 0.97. Where is the 0.97 coming from? Because the new every year, like I did before, the new population is the population the year before minus 3% of the old population. It means every year the population, the new population is 100% of the year before, but you take away 3% of what it was. So it's 97% of its old population, which makes sense. Every year it's losing 3%. So every year the population is 97% of what it was. So it's the old population times 0.97. So this time from year to year, you multiply by 0.97 because from year to year, the population is 97% of what it was. So this is really going to lead us to the same type of formula. It's an exponential function. It has the shape of an exponential. The initial value is 20,000. If t is 0, it's 20,000. That's my intercept right here. The growth factor, it's the b. That's the growth factor. It's 0.97. But how did we get 0.97? Basically, it's the 100%. We're taking away from it the 3%. Is that clear? It means another way of writing it is 1 plus the minus 0.03. With this formula in mind, the growth factor is 1 plus the growth rate. So it's 1 plus the minus 0.03, it means 1 minus 0.03. So if you have summary, before we do a few problems, summary. If you have a quantity that changes by the same percent rate every unit of time, it means either increases by 3% every year or decreases by 3%. That's the scenario I have. So suppose, let f be the function that associates to each time t the value of this quantity at time t. Then f is an exponential function. It means f will have the form a constant a times b to the power t. A is the initial value. It means what happened at t equal to 0. B, which is the growth factor, is always 1 plus the percent growth rate. If the quantity increases, the percent growth rate is positive, like in the first example. And in this case, B is bigger than 1 because it's 1 plus something. If we have a decay, like the second example, the percent growth rate is negative. And then your B will be 1, you're taking away something from it, it will become less than 1. Let us do examples.
Wait,
What?
I was still copying that.
Oh, you don't have to copy, it's online.
Oh.
No, it's online.
I'm like writing the whole thing out. Okay.
No, this is online. All the lectures are online. Is that clear?
Okay.
Otherwise, it will be hard for you to copy. I want you to work with me. I don't want you to copy. The lecture is online. Now, exercise. The first problem, the goal of it is to understand the relationship between growth factor and growth rate. So find the growth factor in each of the scenario below. Water usage is increasing by 3% per year. 3% represent what in this case? Growth rate. Growth rate. I want you to find the growth factor. What's the growth factor?
1.03.
Is Roxanne correct?
Yes.
Right. The percent growth rate is 0.03. The growth factor is 1 plus that. Now, an investment decreases by 5%. Like these days, your investment is decreasing by 100% now. So an investment decreases by 5% per year. What's the percent growth rate in this scenario?
95.
It's minus, and that's crucial. Okay, because the idea that's decreasing, the percent growth rate is minus 5%. It means minus 0.05. The growth factor now is 1 minus 0.05, which is 0.95. Oh, and the way you think about it, it means every year it's 100% minus the 5% of the year before. It's 95% of the year before. It means every year my investment is 95% of the year before. Eventually, I'm going to lose everything if this will go on. But that's the idea. Questions before I go?
Nope.
Anybody? Okay. Now, another one. Just we're trying to just go over those problems. Exercise 2. A town has a population of 7,000 in the year 2005. And it's growing at an annual rate of 1.7%. Let T represent years after 2005 and P of T the population at time T. The question is, find a formula for P of T. Question number 1, is this function gonna be exponential? It means if the formula for it is an exponential formula.
Yes.
Yes, because as we did before, it's growing at the same percent of 1.7%. That's really what tells me, the same percent every year. So we know that P of T is have the form. And if you guys don't see something, let me know. But this is all very new to me. All right, that's the formula for the population as exponential. What is my A and the B?
The
No,
A is 7,000.
you agree with him? It's the
Or
initial.
70,000?
It's what? Yeah.
70,000, not 7,000.
No, what did I
Is it
write?
7,000?
It's 7,000.
Okay.
So that's immaterial. You can put anything you want. Just change my symbol. So 7,000. Let's go with that. Now, what is the B? Sorry. To find the B, I need my rate. What is my growth rate?
1.7.
It's 1.7%. Correct? The growth rate, not the factor. So,
Oh,
is that clear? The growth rate yet, and then I'd see the growth factor. So the growth rate is 1.6. It means every year it's increasing by 1.7%. Let us write this as decimal. It means 1.7 over 100. Am I right?
Yep.
And this is how much in decimals?
0.017.
0.017. That's the growth rate. That's how much the population is growing yearly. Now, what is the growth factor? That's the B. That's my B. It's 1 plus the 0.017. It means 1.017. With me?
Mhm.
Okay, so what's the formula now? 7,000 times 1.017T. So now I can ask you all kinds of questions. All right, so this is my P of T is 7,000 times 1.017 to the power T. So now if I know let us assume that the population keep growing at the same percent rate, may not, but let us assume this is the case. So how much will be the population P after 10 years? Now it becomes very easy. I just put in 10 for T. And let's see how much. Is it a good growth or not? I have no idea. That's 7,000 times 1.017 to the power 10. Somebody, oh, I like that. You guys are fine. No. So it's 8,285. So it's growing, right? Let's take up another problem. Sorry. Same problem as before, but the population is decreasing at a rate of 2%. So what's going to change in this scenario now? Okay, you guys give me the formula. You have 2 minutes for it. I want each one of you to write the formula in front of yourself. Tell me what the growth rate is. Tell me what's the growth factor and put the formula together. Quickly.
Shit. What is it, 2% or 3%? Because the screen went off. I can't see.
Two. So initial 7,000, but it's decreasing at an annual rate of 2%. I give you 2 minutes to give me the formula.
I got it.
Okay. Now, you know, I know your name. I know who is there, so I can ask you questions. There are some students who are not there. I don't know why. Okay, who would like, Alexis, would you like to give us the answer?
What are we looking for again?
The formula for the population.
Is it 7,000?
7,000. What's
know-
the B? Sorry.
Is it minus 0.02?
Yes, why it's minus? You're absolutely correct. So what do you want me to, what's the B? I start upward. The population is the initial value times B to the T. A is 7,000. Let me get rid of that. A is 7,000. I want the B in this scenario. What's the B?
1.02, negative 1.02?
No. B is 1 plus your growth rate. That's the relationship between them. What's the growth rate here?
Negative 0.02.
Yes. Negative 0.02 is just the growth rate. Is that clear? The growth factor is
0.98.
right. It's 1 plus, if you want. That is 0.98. It means every year the population is 98% of what it was the year before. That's really what's happening in mathematics. 98% of what it was. So the formula now is going to be, so I read now my note, the percent growth rate is minus 2%, which is minus 0.02. The growth factor is 1 minus that, 0.98. So the formula is 7,000 times 0.98 to the power t. The B is not the rate. The B is 1 plus the growth factor, which is minus 0.02. After 10 years, the population is decreasing, of course. If I plug in 10 for t, I get 5,790. Questions?
So is it safe, B will never be negative, right?
Absolutely not.
Okay.
No, actually, it doesn't make sense when B is negative. No. Any
Because
other
you're starting
questions?
off with 100, so it should
Yeah.
never be a negative.
Yes. Any other questions? No, it cannot be, you know, if, yeah. Any other questions? All right, let's do the last one. Find, for each of the functions below, find the initial value, the growth factor, and the growth rate. Are you with me? The idea is, my goal here is for you to understand the formula verbatim. So I'm going to take P of t equal 4 times 1.4 to the power t. So I'm giving you this formula. And I'm asking you the following. what is the initial value? The initial value is what's the value of your function at 0? That's the initial value. So
4.
what's the initial value?
4.
4. Now, what is the growth factor? Let me pick somebody. I mean, I'm trying. Lily. Lily. Lily.
There she is.
Yeah, she's there. I know. Unmute yourself and tell me, what's the growth factor?
No, I'm not coaching. Now I can't do this. I can't do this. No.
Okay, I'll switch from Lily. Hunter, are you with me?
40.
You guys
Lily
have
put
to,
in chat that the growth factor was 1.4.
yeah. Somebody wrote it. Oh, I'm sorry.
Lily
Lily
wrote
did.
1.4.
Yeah. I'm sorry, Lily. Okay, she's absolutely correct. 1.4. What is the growth rate?
40%.
40%. So you can either see it, like when your classmates see it, or if you didn't see it, what's the relationship between growth rate and growth factor? The growth factor, if you didn't see it.
Push your
is-
paper up a little bit because you can't
Thank
see
you
what
very
you're
much.
writing.
Yes, that's what I want.
Thank
I
you.
want you guys to tell me what's happening. 1 plus the growth rate. That's the relationship between them. So it means 1.4 is 1 plus the growth rate. And that's what I am after. Now, if I solve for it, I'll get 1.4 minus 1, which is 0.4. Or you can just see it as your classmate did. It means that the growth rate here is 40%. And what does this mean? What does this mean? It means if this formula here represents a population, what do we know about the population? We know, let us say that the unit is million. It means this is a population that started with 4 million and it's growing by 40% every year. That's how you understand this formula. It starts by 4 million, and so it's starting by 4 million, and it's growing by 40% every year. So it starts 4, after 1 year, it's grow by 40%. Another year, another 40%, and so on and so forth. All right, last example. And again, you guys, I want you to work it out with me. So I have my population is 5 times 0.92 to the power t. Again, I want initial, which is always easy. I want the growth factor. And I want the growth rate. Okay, I'll give you 2 minutes. We have that. Okay, who's ready?
I am.
Okay, go ahead.
The initial is 5.
Okay, is she correct? It's just the value at 0. So it means if here I'm sketching the graph of P of t, this is the 5. It's right there. What's the growth factor?
0.92.
What's the growth rate?
Negative 8%.
Negative 8%. Is she correct?
Yes.
Let us see. You didn't see it. Let us see. Let's see. Then how can you find it?
100. Oh,
Okay, 0.92 is 1 plus the growth rate. If you solve for it, it means, Roxanne should tell me to lift up my paper. The growth rate is 0.92 minus 1. It means minus 0.08. That's the growth rate. So this tells you immediately that let us assume P of T represent population. The minus tell you it decreases, and 0.08 is 8%, decreases by 8% every unit of time. Let's assume time is here. So when I'm sketching the graph, what type of graph I'm gonna get? What the function is gonna do?
concave up.
It's gonna go down, 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 just like that. That's how it's gonna do. Is that, yeah, it's decreasing. It's not the concavity I care about here. Is it increasing or decreasing? It's an absolutely a decreasing function. And it will never be 0. I mean, it will never hit the t-axis in this case. The formula is 5 times 0.92 to a power. Regardless what number you put in here, this is gonna be always a positive number. So it's gonna never hit the horizontal axis. It's gonna just keep going down and down and down and down and down forever. Okay? All right, so that's it for today. How did it go? Were you guys able to follow?
Yeah.
Yes.
Okay.
It was better than I thought it was going to be. I was freaking out a little bit.
Yeah, I know. All of
Yeah,
you. Yeah, no.
this worked pretty well.
It's working very well. All right, so what I want now, you guys gonna have homework as usual for Wednesday. You do it. And please, when we start, I want questions. So I will not do questions by myself. And I will put the lecture tomorrow, so you don't have to write when I am writing. Second, as far as the quiz is concerned, I still would like to give you a quiz every Wednesday. All right?
Okay.
Okay. Yeah, we have to do it. I have to know whether you guys are with me or not with me. I mean, that's crucial for me.
Are you going to give them through Blackboard?
Yes, I'm going to give them through Blackboard. That's the only way I have. And so I will give you a time limit, like, you know, for 30 minutes or so to do the quiz. And then you guys will copy it somehow and upload it into Blackboard. And I will grade it and give it back to you. Not give it back to you. I mean, give you the solution.
Okay.
Now, one thing I'm going to do for tomorrow, I'll send you an email. I'm going to give you like a practice quiz, which is basically not, I don't want you to take a quiz or anything. What I want you to do is to practice the process in case you don't know how to do it. So just write your name on a piece of paper. The quiz will be to write your name on the piece of paper and upload it. And the only goal is for you to practice the process before Wednesday, because Wednesday you're gonna have some kind of a time limit. Okay?
Okay.
Wait, wait, what's happening?
Tomorrow, I will send you an email. I will just send you something like a practice quiz. It's not a quiz. I will just send you a quiz, tell you, write your name on a piece of paper and upload it into Blackboard. The whole idea is to practice, so Wednesday you will be ready. Got it?
Okay, but like going forward, we're gonna continue. Like if this like is successful or whatever, going forward, we're gonna be taking quizzes every Wednesday, right? As usual.
Yes. Yeah. I have to. I mean, you have to stay. You know, I have to know whether you guys are following me or not following me. I mean, it's unless you have any other choice. I don't.
And for the test, we're still taking it April 12th or something like that.
Yes. I'm not changing anything for now.
Okay.
Okay, I'm not gonna change anything.
Okay, can I ask that the time limit be more than a half hour? Because usually I'm in class like an extra 30 minutes trying to finish the quiz.
Yeah, I'm like one of the last ones to leave. You know this.
Okay, we will worry. I will give you, you know, this Wednesday will be a trial. Okay, I mean, I will put a grade, but I will give you like, I will see. I'll give you maybe 45 minutes.
But you just said for the quiz, you just said it's gonna be writing our names, right? Or is it actually gonna be a real quiz?
Oh,
On
that's
Wednesday.
for tomorrow.
That's for tomorrow.
Yeah. On
Oh,
Wednesday.
there's two different ones?
Tomorrow is the practice
me.
quiz. Tomorrow is the fake quiz, and then Wednesday will be the real quiz.
Oh,
fake quiz.
okay.
Got it? Thanks, Dijon. Got it? Tomorrow is just
Yeah,
fake.
thank
Just
you.
to
But
make
you're
sure-
gonna send out an email too, right?
Yes, yes, I will send you email. Yes, yes.
Okay.
And any other questions? Now, some students didn't show up. I don't know why, because I don't know. That's how we're gonna learn this semester. That's it. We don't have any other choices. Anyway, I'm gonna hold office hours, and I'm gonna hold office hours the same way I used to. It means before class, from 4 to 5. And I'm gonna send you the URL for the meeting for the office hours. So if you guys wanna join prior to that in the office hours meeting, and you will be able to do that and ask me questions.
Okay.
So I'm trying to do it as close to what we did in class as possible. And you guys can email me if you have questions. You know, I'm stuck at home anyway, writing lectures. So I have nothing else to do.
Some of us still have to go to work, okay?
I'm sorry. Just be safe. Be safe. Be very, very careful. Very
Stop
careful.
ordering so much stuff from Amazon, guys. Thanks.
That's our, you know, Amazon is the only way out now. Anything, we go to Amazon.
We're hiring if you guys need jobs.
Oh, for real?
Yeah, they're hiring 100,000 people and they're paying an extra.
Okay.
$10
Oh,
an hour.
I'm gonna text you separately then. Thank
It's in
you.
Gary.
I don't care where it's at.
Well, it's
Okay,
close.
be careful, guys. Be careful.
right.
Be very
You guys
careful.
have a good day.
Yeah,
All right,
good
thank
night.
you.
Bye-bye, guys.
Thank you.
Thank you.
All right, thank